All right, hello everyone, and welcome to our third webinar, which in a series of 5 on managing weeds in an organic production system. Thank you for taking the time out of your day today to spend with us. So I'm Karen Clausen, I'm from the Manitoba Organic Alliance. In addition to hosting the series of webinars, we also produce a podcast called Grain on the Brain, and we're about to publish a new episode on soil health, so stay tuned for that. And you can find out more about us on our website at manitobaorganicalliance.com. Our partner in bringing this webinar series to you is the Natural Systems Agriculture Group at the University of Manitoba. We have lots of different people in attendance for these webinar series. We have over 110 people registered from all across Canada, mostly in Manitoba, all across Canada, and also the United States. So we all have different climates and weeds, but we're hoping that the knowledge that you're going to be getting from this webinar series will be applicable to all of you. So we'd like to thank our sponsors who've made this extension work possible. For this webinar, we have FCC, Ents Brothers, Weed Surfer, Broquette, and Fresh Hemp Foods. We also are pleased to have a grant from the Canadian Agricultural Partnership funded by the federal and Manitoba governments to support our extension activities. So if you're an agronomist, you'll get to receive CCA credits for each webinar. At the end of the webinar, I'll put up a unique code that you can scan with your phone. Later today or tomorrow, you'll receive an email with a link to the recorded webinar that you can view at your leisure as many times as you like. If you have any questions that occur to you during this presentation, please type them into the little question box. We'll get Catherine to look through them as we're going along, and if we have enough time during this presentation, we will answer them. And if we don't have enough time, we will email you the answers to your questions later. So feel free to ask as many questions as you like, and we'll get to them at some point. I'll now pass this over to Catherine Stanley, who's a research associate with the Natural Systems Agriculture Group at the University of Manitoba.
Great, thanks Karen, and hello everybody. Thanks for joining us today from wherever you may be. So I'm going to introduce Dr. Steve Shirtliffe, who will be participating in this webinar on wild oats. Even just seeing that picture that Karen's posted is enough to stir nightmares in most of us, I think. So just as a brief introduction of Steve, Steve was raised on a grain and oilseed farm in Manitoba. He's now abandoned Manitoba and moved as a resident to Saskatchewan, where he is a professor and conducts research and extension on organic weed control and agronomy. Steve completed his PhD at the U of M, actually on wild oat management, so perfectly suited to this topic today. I actually completed my master's with Steve, and so I'm really excited to be hosting the webinar today, and also very much looking forward to the content as I am continuously battling the wild oat patches that Steve created at the Carmen Research Farm during his PhD program over 20 years ago. So with that, as Karen mentioned, don't forget to ask your questions in the question box. I'll try to include them throughout the webinar, hopefully not just at the end. And with that, maybe Steve, I'll hand things over to you. Steve said that due to his lack of COVID haircuts, he's going to stay off video for this one, but you'll be able to hear his lovely voice. So Steve, thank you for joining us today.
Well, thank you very much, Catherine. It's great to talk to you again, and it's great to talk to some farmers out there. I always enjoy that part of my job, being able to be out there. Yeah, and Catherine mentioned that I did my PhD on wild oat research. I kind of and I established a patch out at what at the time was a new research farm out at Carmen back in the mid-90s, and drove a combine through there and tracked the dispersal of wild oats by that combine, and looked at some patch dynamics and other things. And I spent a lot of time with wild oats over the years. I've also done a fair bit of work, not recently, but when I first came to Saskatchewan for the first 10 years, we looked at managing wild oat and tame oat, which is a problem for both conventional and organic growers, because of course for conventional growers there isn't any herbicide, because wild oat and tame oat are essentially the same species. They're classified as different species from kind of a taxonomic point of view, but in terms of their genetic similarities, they're so similar. They're really, if we didn't have a cultural attachment to one, we'd probably consider them almost the same species. Essentially oats and, as the name would say, wild oats. There's not really that much difference between them, but of course, that wild oat has that those two main characteristics that we get rid of in tame crops is the ability to self-disperse, which we want seeds to stay on the plant so we can harvest them, and seed dormancy. We don't like having, when we plant our seeds in the ground, we want the seeds to grow. We don't want them to stay dormant, but wild oats has that ability to become dormant. Of course, every farmer knows that those seeds that stay in the ground, they can stay dormant for some time. But anyway, so that's kind of the background. I know as far as wild oat is always, this may sound weird, but wild oat has always been pretty much my favorite weed. It's a keen nemesis, as Catherine's has inferred, so it's yeah. So anyway, so Catherine, what would you like to know about wild oat?
So yeah, I put together a few questions to kind of guide the conversation, and you mentioned 2 points already for my first question about self-dispersal and seed dormancy, but I was wondering if you could provide a bit of a background, of the wild oat physiology, and like what about the plant itself makes them so competitive against both tame oats and other crops that we grow on prairies.
Yeah, everybody, I think people may give wild oats a bit too much credit for its competitive ability, because if you look at it plant for plant, any of our cereal crops, like one wheat plant, one barley plant, or one oat plant is going to be more competitive than one wild oat plant. They don't have to be that competitive. They're just trying to get enough resources and to reproduce. So they're not, our crops have been selected for kind of working well together and making a lot of yield. Our weeds, they're kind of evolved just to reproduce and to get by. So they're actually not as competitive as most of our cereals. Of course, when you start comparing them to lower growing crops, like, well, you guys don't grow many lentils there in Manitoba, but flax, or I can't recall. I think Rob Golden's done some work in soybean, that they are more, that they, and dry bean for sure, that they are, crops that they can overtop. They are some of them are kind of, but of course that is the issue. But the issue is, of course, you can get a lot of them if you get a dense patch, and they can compete, so there's nothing magical about the competition of wild oat, though. They are essentially doing what most plants do, is they're just taking up space. And that's, I always say to farmers, that that's a key thing of when you're managing a crop, is always think of it that you're managing a solar panel, right? Because everybody likes to think, especially conventional farmers, they like to think of growing a crop as, what do I have to buy to put in it? What are the inputs I have to put into it to get it out of there? And well, there's the two most important inputs to growing a crop you can't control, and they're light and water, right? And those are the two main things. And so the light is usually fairly easy if you have enough of everything to go there, except when weeds come in, because what a weed is doing is just, instead of having your crop, which acts as a solar panel, uses that energy and well, essentially has two halves to its life. The first half of any crop's life will be building its own solar panel. You put a seed in the ground and it grows vegetatively until it can have a good solar panel to absorb as much energy, sunlight energy, as possible. And to do that, it has to take up water and soil nutrients. Once it does that, then it switches to the reproductive phases. It flowers, and then it uses that solar panel to produce seed yield, which we usually want out of it, right? So anytime you have weeds in there, all the weeds are doing is basically taking up space, because they're essentially making a hole in your solar panel where that energy is not going towards your crop. So basically, how much space the weeds take up in the canopy is a good indication of how much they're competing. So, it's not people, like, I've been a weed scientist, my whole life, and we like to get caught up on the things we can easily measure, like how many weeds are there per how many weeds are there. Well, the number really doesn't matter. What really matters is how much space they're taking up. So if they're taking up a huge part of your canopy, they're causing a lot of yield. If they're just a few little things down at the bottom of your canopy, they don't matter. They're not really causing a yield. Maybe they'll make a few seeds and continue, but that's about yeah. So that's kind of some of it. I think you're muted, Catherine.
Thanks, got it. So I think that's like a really good point. I really like your analogy of referring to weeds and crops as a solar panel. And, you know, often when we talk about cultural weed control, it is about putting the competitive advantage in the hands of the crop. So I think sometimes we look at weeds as an individual plant. And I guess my question back to you is that when you are looking at wild oat control, how do you then manage a patch or manage a competitive canopy or approach that situation versus an individual plant?
Yeah, well, they're kind of there's two different things, and but you're essentially managing, when you're managing a patch or anything like that, you're trying to manage for the long-term benefit, and that gets you into some of the things that maybe we'll talk about later, like trying to manage seed dispersal or seed production in the plant. If you're managing seed production or seed dispersal, that single year damage has pretty much all been. For example, weed surfer. No, that's not coming from my end. You could see that if you're managing, by the time that you have viable seeds being done, that weed has competed with the crop, so it's good. It's taken the yield out of that crop for the year. Well, I was going to say, I see that you have Weed Surfer as one of the sponsors for this. And, you know, crop weed clipping, that's something that can be done in short crops to reduce seed production in wild oat, for example. And we've done some work in where we've manually clipped wild oats on top of the crop canopy, and that we can get a little bit of reduction. Unfortunately, with our taller crops like wheat or barley, the height difference between wild oat and tame and the crop isn't large enough to really effectively reduce that. If you get into shorter crops like lentil, which we've done work in clipping, not in wild oat specifically, but in wild mustard, it can work quite well. You can reduce that seed return by quite a bit, but you have to have that huge height differential. And I know we've tried to use implements that have an ability that have some ability to comb through the canopy, but it's just, you just can't get enough of those weed seeds to make an effective difference unless you're using it on top of a canopy of something like lentil or flax, or perhaps even soybean would work. You know, I've no experience at all in soybean. But you know, for our Manitoba listeners, that you could clip on top of that when you get kind of weed escapes that come through, and of course that's nothing new. If you know, I remember looking in old you know that farmers used to drive those trailers, those 3-point hitch trailers with people sitting on them over the bean fields to pull out the tall weeds in the old days. You know, that sort of thing, to have kind of a bio-robotic weed control method on that. But that, so for seed return, yeah, that it doesn't affect your single season one, but it can affect somewhat depending upon how much seed is in your seed bank already. And of course, you know, one thing we looked at with my PhD way back in the day was we didn't even call it harvest weed seed management back at that time. We called it chaff collection. You know, Martin Ends, I think the Glen Lee farm had this old New Holland combine that had a chaff collector on, because somebody had done some experiment about feeding chaff to cattle. And we decided to look at it to see how it affected wild oat seed dispersal. And yes, indeed, what we found with wild oat, which is also interesting, is that the timing of the seed dispersal in wild oat is very interesting. And that wild oats, and most farmers will have seen this in their field, as the crop starts to ripen, and the predominant crop is normally wheat that wild oat would have co-evolved with. As it starts to ripen, just as the crop is ripening and getting close to being ready for harvest, the wild oat seeds are in the process of falling off. They've kind of co-evolved this timing of dispersal to coincide so that their seeds can fall off before you go out there and harvest them, so you don't take them off with your crop. And there's still some that are on there, but we kind of played around with the harvest time and then tried to find ways to utilize that method to try to maybe take more seeds off the field. And we never were able to, you could never get out there early enough to capture all the wild oat seeds. Your crop would have been too green. But what we did find out, and this was through some computer modeling, that if you do have wild oats and they're patchy and you don't want them to spread, that actually just letting them fall off in that patch is not such a bad idea, because that patch is going to have a ton of wild oat seeds already in the seed bank. And when you drive the combine through there, the ones that aren't shattered off, that the combine takes in, as the combine's processing those seeds, it'll drive further down the field and spread them. So if you delay your harvest a little bit, and maybe switch, like virtually, straight combining is almost dominates the there isn't as much swathing as there used to be. So straight combining, and after you allow most of those seeds to fall, it does seem to be a bit of an advantage for that. And we're talking about the controlling seed side now, not managing competition.
Thanks, Steve. That's great. And that answered a lot of my questions about patch dynamics. I think it's something worth understanding. We tend to think of lots of weeds on a per plant basis. One thing that I was thinking about when you're talking about, just letting your weeds fall down into the patch that they're coming from at harvest time, I agree. I think that getting your wild oats at harvest is very, very challenging, especially in crops that kind of like oats, that mature a little bit later. I was wondering, especially for the organic growers that are on the call, how would that idea of like containing your patch play into fall tillage or fall field work? What are some things that you could keep in mind to make sure that you're able to contain your patch into smaller and not spreading it further?
Yeah, well, that's a really good question. And there's this whole, you'd be probably talk to somebody like David. Is it David Lobb over in soil science that does the work on tillage erosion? He probably has a better idea, because there's been some old work done on kind of tillage movement of weed seeds, and it isn't that much, maybe usually about a meter or so. So it will make your patch a bit bigger, but we don't. We don't really know that much about it, so it's not going to be. It's not that big of a movement as it would be for for a combine, where it's actually taking the weeds in, and like a lot of modern if you got a lot of combines, can move quite quickly now. Some of the newer ones are quite powerful. So as they move along, if they're moving at 4 miles an hour, or if you think if they're moving at 4 meters per, or let's say 3 meters per second, and it takes 10 seconds for them to process the grain, that's moved 30 meters. So the tillage erosion, the tillage movement isn't going to be huge, but it is something that happens every time you till it, and it actually moves all of the weeds in the seed bank. So not just the fresh ones, or the ones that haven't fallen off. So it potentially moves all of them that are within that tillage layer. So it could be a deal, but tillage and all, maybe I just had a lab meeting this morning, and I had one kind of minor rant there, and maybe I'll get on maybe I'll have another little rant here. When you're an organic grower, you shouldn't confuse yourself with being a no-till grower. You got to till, right? You got to till. So you need to till the soil in order to kill weeds. That's your only big tool you have, to kill those. And the big thing is not wild oats. Of course, it's the perennial weeds that are going to start growing, because essentially all annual farmers have to beat back perennial, your ultimate competitive plants, your perennials that really want to take over the system, because we come from a system that was a perennial grass system, You know, in Manitoba, you can see those beautiful remnants of tall grass prairie, what it once was like. And that's what the ecosystem wants it to be. So if we want to keep growing annual crops, we have to go out there and till. And yeah.
No, I appreciate that comment. Thanks, Steve. I have lots of other questions that keep popping up in my head, but I'm going to try to stay focused on this list. We do have a couple questions in the chat, a couple related to mechanical weed control, which we'll get to in a minute here. But before then, I guess I wanted to focus a little bit on cultural weed control. Like I mentioned before, making the crop more competitive in weeds, in the presence of weeds. And I was wondering, you know, I know that this conference call is based in Manitoba, but we do address farmers all over the prairies. And as Karen said, there's some farmers from the States. Are there certain crops that we grow commonly in some of these crop rotations that are more competitive with oats? What about, you mentioned lots about the solar panel and canopy closure, what makes crops more competitive? And what would your ideal crop rotation be to lessen a wild oat issue? So it's a bit of a loaded question, but I'll throw it back to you.
Okay, well, ideal crop rotation. Well, you know, it's anytime you can. So if you work at two levels within the crop rotation, the one would be to have competitive crops to keep the for those wild oats that do occur in your crop that you're growing, your cash crops that you're growing. The more competitive it is, the less seed production there's going to be. So if you can keep that seed production down, it can reduce your problem from getting out of hand. But if you can also have alternative, you know, I mentioned already about that timing of dispersal. If you can also have alternative crops in there, and that almost always means going to a situation where you have some type of forage crop in there that's being harvested earlier, so that you can, you know, if you grow barley as a forage, and if you watch your wild oats and make sure that that the seeds don't start falling out if you cut your forage before then, which shouldn't be a problem. Neil Harker did a lot of work on that. You show that you can that is a great way to deplete the seed bank, because you're not allowing the seed to return to it. Of course, having stands of perennial forages in there, rotating in a 3-year stand of alfalfa. My old friend Pam Ominski, you know, did a survey, God, almost 30 years ago, looking at wild oat populations after alfalfa versus after wheat, and there's a huge difference. You know, alfalfa almost gets rid of those wild oat populations there. You know, as for cultural things to manage it, I don't know if you want. I've got a few slides. I could run through a few slides. If we could throw that slide, if we could switch to that slideshow, if that comes up there, we have a technical assistance there.
I think Laura's working on that.
Show my main screen. There we go. And I only have one screen hooked up here.
I can see your slides.
Can you see them? Tell me when I can begin, but maybe I'll. This is actually the wrong. I'll start here. So maybe are we getting the video? Maybe I'll just start talking about it. The main thing again. Pardon?
Your slide says controlling wild oat and tame oat, so that's good.
Okay, perfect. Okay, so I'll just step through here. I'm not going to spend a ton of time on each one, because I don't want this to turn into a lecture. The one thing is that the timing of emergence is important with wild oat. If wild oat, I mentioned this before, again, that solar panel idea. If you have some weeds that come after, if you have a competitive crop, let's say like you're growing some oat because there's a great market for organic oats, right? You know, if every time I bite into a Cliff Bar, and I bit into one about a half hour before this, so I'd have some energy, I was eating organic oats out of there. And if those wild oats emerge after your main crop, you're in a good situation, because your main crop, and this is work that Chris Willenberg did way back in the ones that emerge after it, they're about half as competitive as the ones that if they emerge one leaf stage later, they're not nearly as competitive. So if weeds are at the bottom of your canopy, if they're smaller, and again, because size really matters with things. And here we go, yeah, 25 wild oats that cause 10% yield loss when they emerge with the crop, but they only cause 3% yield loss when they emerge one leaf stage after the crop. So they basically don't matter. So you don't have to worry about. Delayed seeding is something that's been advocated for years. That's okay for most crops, but what you have to realize, and especially in you know, it depends on the crop, but in a lot of in virtually any crop, the later you seed it, the lower your yield potential is going to be, especially if you have moisture limitations coming in there. So you have to realize that, and that most of your weed seeds that you have to wait basically till the end of May till you have reductions in it. But then crop varieties, I'll say right now, the differences we find in crop varieties aren't huge. I've spent quite a few years looking at this, and we picked very different ones, and the differences in competitive ability were not really large. So I usually don't worry about it. Grow with if you're growing oat, you grow up what the market wants. That's what your variety choice has to be. What has high yield potential? And we know what has high yield potential under conventional conditions almost always has high yield potential under organic conditions. Maybe that's shifting a little bit as our crops are getting a bit lower, a bit shorter, but even some of the semi-dwarf oat ones actually had good yield potential under organic conditions. Crop seeding rate, this is your big hammer. This is your big, we talked about little hammers and big hammers for doing it. Increasing the seeding rate, you know, if in oat, it's a difficult one to talk about because because the bushel weight of oat is so low relative to, but you know, but you want to be getting with cereals under organic conditions. I'd like to see at least 40 plants per square foot out there. Your seed isn't costing that lot, maybe even 50 plants per square foot. And so do the math on that. You know, that will normally mean at least 2.5 bushels per acre for wheat, depending on the kernel sizes. And oat, that's probably going to be around 4 bushels per acre. But again, the bushel weight in oat means nothing because the real bushels aren't there. Crop seed size can have an effect. We looked at that year. A good quality, a good seed lot that has lots of bigger seeds, they are more competitive. But if you are seeding on a volume or a weight basis, when you seed ones that have smaller seeds, you're actually seeding more of them. So they almost cancel each other out a bit. So I don't worry too much about that. Fertility management, you know, if you're going to be growing I know in some cases, or, you know, if you have a green manure plow down, or if you've applied some manure as an organic farmer, you'll have shifted the nutrient balance in here. What we found in looking at this is that actually the relative competitive ability of wild oat versus your crop doesn't change. There is that idea out there that weeds are somehow so much better at taking up nutrients than the crop, and there may be some evidence for that in some cases, but overall, especially in what we did in the field, it didn't change, so that wasn't a big deal. Mechanical control, we alluded to that, you know, that harrowing for wild oats is pretty hard, unless you get it at the right time. The trouble is that wild oats can sometimes emerge from deeper in the soil, so they're harder to pull up, and they don't kill by covering up that much. So they're one of the harder weeds to kill with mechanical weed control. Rotary hoeing, I don't think touches them, and for, you know, that's been under our organic rotations and everything, that's been our go-to implement. And that kind of leaves you. Maybe harrowing can help a bit, but it's there. What I did want to mention though is that there is that idea out there that tame oats, you can't harrow tame oats, and that's not true. You know, we've looked at that, and they're as tolerant as wheat to it. There's been work done in Europe, and the same results have happened. So, but there's that old myth out there, and sometimes don't believe those old myths, and so they're just as tolerant. And finally, combining tactics is your best bet. And this is work that Dilshan Ben-Aragama did. And what he found, and this is all weeds under organic conditions, that increasing your seeding rate and harrowing together gave you 25% greater yield. And in-crop harrowing, this is for weeds in general. It actually did help our wild oats control. We did get some control with them in the years that we did it, but it wasn't as good as we can expect in some other crops. But basically, I'll get to the end one here, is that what we found was that when we combined a higher seeding rate, in-crop harrowing, and a competitive cultivar if you have one, we're able to reduce our weed seed production, or our weed biomass and seed production, by about 71%, which is quite good. And we've since gotten better at that. If we look at work that we've done in lentil with Alexander Alba, he built upon some of Catherine Stanley's work when she did her work at the University of Saskatchewan. We were getting, in lentils, we were getting about 80% weed control by using a higher seeding rate and mechanical weed control under organic conditions. So it can work. So we can go back to, I'll end my slides there. I can go back to talking to Catherine.
Awesome. Thanks, Steve, for sharing those slides. I think a lot of that information is really helpful, and especially the point of the importance of combining tactics and really having a plan and an integrated weed management strategy. So thanks. I'll go to one question, since you were touching on mechanical weed control. There was a question from the audience asking,
Perfect.
what is, so it's kind of a twofold question. So one, what would be the economic threshold of wild oats in certain crops like wheat or peas? And what is the best management to keep them below the economic threshold, which I think you touched on some of those points, but specifically to mechanical weed control and harrowing? Are there certain harrow types or mechanical weeding tools that do best on wild oats?
Wow, I feel like I have memories of Dave Kellner here. Him and myself and Dave Kellner we used to be such nerds that, well, we are probably still such nerds, that we used to argue over economic thresholds, if they were real or if they mattered, if they didn't matter. But anyways, so your threshold in terms of an organic, before I go down a huge rabbit hole with thresholds, I'll just say it's even that the economic thresholds that are out there are not well established, especially when you look at multi-year effects, because you have your damage that signal year, but you also have the future damage from the weed seeds that are produced. So, a lot of farmers, conventional and organic, essentially try to operate on a threshold of near zero, which used to be considered taboo. But these days, I think weed scientists have started to realize that if you can keep your weed populations low, it can be a very good thing. But once the genie's kind of out of the bottle, then you can kind of just manage them as on a threshold basis. What I would say, the most important thing when considering mechanical weed control is to really look at your differential tolerance to the job that you are doing. I wouldn't worry too much about an actual density number. Of course, if you have, like, maybe less than 1 wild oat per square foot, averaging, or 10 per square meter, or even, well, actually those would still, if you had 10 per square meter, it would still pay you. If you could get, well, let's say, you have to figure how much your control you're getting. If you get 50% control on 10 per square meter, it would probably still cover your diesel fuel cost and your machinery wear and tear, I would guess, to go across there. So if you have a reasonable infestation, it would pay to do. But what you really have to look at is the relative tolerance after you go over it. And that old adage of never look behind when you're harrowing isn't true. If your crop looks terrible, and you have some unrealistic idea that it's going to come back from this mechanical weed control, that it's, if you've covered up the crop row and the crop is in a leafy stage, if it's like a 2-leaf stage and it's completely covered the crop row, it doesn't come back. it doesn't come back. You know, you can go back out there, put a little pin flag by there, come back a week later and brush it off. You'll see that those leaves are too weak to push through the soil that's on top of them. You know, that it's a very vulnerable stage usually when you're trying to do it. So you have to be very careful. In many cases, if you have a really good catch of your crop, and because the differential tolerance of wild oats is so little, and your wild oats are not that the density isn't that heavy, you may be better off leaving it. But there's no easy numbers here. Perhaps the best way is like Catherine and I were talking earlier. Catherine, oh yeah, Catherine Sadler, yeah, is to think about what proportion of the space are they occupying. And their wild oats aren't going to be as competitive as a wheat. So if they're only occupying 10% of the space or 5% of the space, and remember, our eyes tend to find things like weeds and really fixate on them. You know, it's kind of like when somebody has a drop of, you know, a soup stain on their tie. You know, there's the whole tie there, but the only thing you see is that stain on the tie, right? So we can be like that when we're looking in fields. So in some cases, if you have a really competitive crop there and you've tried harrowing it and it's hurting the crop a lot, you may be better off not doing it. But unfortunately, there's no hard and fast rules and no rational, there's no decision support system to really do this. Yeah.
No, I appreciate that. And I think last week it was that we heard from Jason Peters and Aaron Silva, and they talked a lot about how weed management and organic production is never just a recipe that you can follow. There's not an instruction manual, and it is a lot about thinking ahead and planning and looking at your particular situation. So thank you for answering that. There are a couple more questions here about mechanical weed control per se. One of the topics that I know that you've done work on and we've done work on, and you mentioned it, is clipping, either with a comb cut, weed surfer, swather, whatever. There are different forms of clipping. There's a couple questions here, and one that I was curious about as well. At what stage does the seed of a wild oat become viable? So if you clip it when it first heads out, will it still produce seed or not? And then there was another question here, also about seed, related to seed viability. If it is viable, once it hits the ground, how long is it viable for? So kind of a twofold question again for you, Steve.
Okay, sure. Unfortunately, they become viable. Well, of course they have to flower, right? They have to flower. And I think, you know, certainly by the time, you know, I'm gonna, you know, it's funny, I was part of a research project on the Brianna Tideman, and I don't think we've published this data yet. I should have done my homework and refreshed myself on what that final report said. But what I'm thinking is that, you know, I think, you know, I would suspect it's somewhere around where you'd be wanting to get milky to soft dough stage in terms of it. I know they actually will disperse when they're still even before the soft dough stage. So, and they are viable at that stage. But when they're watery, I wouldn't worry about it because they're not going to have enough carb. Even if the embryo is viable, it's not going to have enough carbohydrate reserve to make a proper seed. When it hits that seed bank, yeah. So yeah, you know, I would, if they haven't dispersed yet, I wouldn't worry, because they start dispersing really soon. As soon, you know, like like those top ones will start falling off. You know, like you had that wonderful picture they're showing, those 3 huge, beautiful, plump wild oat seeds at the beginning there. When those fall out, those are of course going to be viable. But interesting, when wild oats a bit like canola. When those are ripened, there's still others that are still producing down at the bottom of the canopy. But it's actually interesting enough, there was some old unpublished work done down in Bruce Maxwell's lab that those ones actually, those big fat seeds, those first ones that fall off that are produced over top of the canopy, they do have a lot better longevity in the seed bank, and they are more And they do, of course, they're a larger seed, so they will have more vigor when they come up. The second part of the question was referring to, I think, about how long they can last, or maybe how much dormancy is in them. So those seeds will be dormant when they first hit the ground, and that's why, everybody, you guys in Manitoba know that, in the fall, you guys usually get a bit of moisture in the fall, and people till, and then you get a nice growth behind where your combine went, and you can go drive around and see who's good at setting their combine and not good at setting their combine by how dark the green swath is behind where the combine went. And or you can argue about what combine's better, the green machine and the silver seeder, and get people arguing about combines in the background there. But anyways, but one thing you'll notice is that wild oats almost never grow in the fall, right? Well, that's because they're programmed. That's because they're essentially not programmed, is that they've evolved a mechanism by which they can sense what season it is. And how they do that is that the seeds have to get cold for an extended period, and you have to get cold usually for about 2 weeks, and then they have to warm up again. So if they've been cold for about 2 weeks and then warm up again, then they're ready to germinate. Not all of them. Some of them will have varying degrees of dormancy in them, so not all of them in your seed bank will grow. But that's when some of them can grow. But then if it's been hot for an extended period, like it is in the summertime, and so the wild oat seeds that are in the seed bank, so it's been hot all summer, they've been hot, they have a physiological mechanism by which they won't grow until it gets cold again. So that's how that mechanism of only growing in the spring. Interestingly enough, of course, the alternative mechanism is also present there for weeds like stinkweed, which are winter annuals and grow in the fall. And wild oats can evolve the opposite mechanism, because if you go over to Europe, the wild oats, where the winter annual crops are common, the wild oats are programmed. The wild oats have evolved to not the spring. So they have these wonderful mechanisms that that we can watch evolution. We can watch evolution in action. Yeah.
Thank you. Yeah, it's fast. I think it's fascinating as much as they drive me crazy. I'm always fascinated by the way weeds can change just based on our management practices. I think that's just an important thing to touch on, is that, we talk a lot about herbicide resistance and resistance being an issue that mostly conventional farmers deal with, but it is also something that to keep in mind on organic farms, that weeds do evolve over time and they will respond to management practices, and that is the importance of crop rotation, changing up your management practices and things like that. It's still something that will take a bit longer, but it does affect.
Yeah. Well, too. There's two mechanisms there. The first is the community change, right? And so weeds that tend not to be a problem in conventional systems, like like wild mustard or lamb's quarters, which are which kind of in most cases, if they get a whiff of 2,4-D or MCPA, they will die. They can become problems under organic conditions, or when they evolve herbicide resistance. So that's the first thing, is you get that shift. The evolution within a species can happen. You can get things. The thing is that the one good thing in organic weed control we have going for us is that our weed control mechanisms usually aren't like 99.999% effective. So if you're only killing 60% of the weeds, the evolution is going to be quite slow in having there. The midge tolerant, like growing midge tolerant wheat, having 10%, just having 10% of the susceptible in there is enough to essentially delay resistance for an extremely long time. So by not having perfect weed control, that can essentially delay the resistance to tillage resistant wild oats. And some of the things, like if you're gonna inter-row tillage, which you worked on, if you're it's pretty hard to evade that if you're growing in between the row spacing. There's pretty hard to have a mechanism to a wild oat isn't gonna evolve Kevlar. But some producers may have some ideas out there of what's happened over time. Yeah, they're the good observers. All I've done in my career is I just take what farmers have done and what the really innovative farmers have done, and I quantify it and I mess around with it because I can do that without worrying about my livelihood, because I can make more mistakes than organic farmers, and then come back and say what works and what doesn't work.
Yeah, no, true. Thank you. So we have lots of really good questions on the thing, and I think we're at 15 more minutes until 1 o'clock. One of the questions that just popped up here was actually my last question. So I will ask this and then I'll go through some of the other ones, time permitting. So the question was, you know, I know that you've done lots of work with drones. I actually received my radio operator's license when I was a grad student with you back in the day. And I was curious, specifically for patchy weeds like wild oats, how can we use drones, or are you looking at how to use drones and drone technology to understand the spread and management of difficult to control patchy weeds?
Well, you know, if you know, maybe I'll use an analogy here. It's when you're learning to ski, you don't only the foolhardy will take the chairlift up to the top and try to go down a double black diamond slope for their first run. And so we're just learning how to use crop imagery to sort out weeds and that sort of thing. So we decided to stay on the bunny hill, and we're looking at managing. We have a current project where we're looking at finding kochia patches, of using imagery to find them. We're associating it with the soil characteristics, the salinity and landscape position. And we're actually able to utilize both UAV and UAV imagery for this as well. You know, even some of the satellite sources that are out there now, because of the differences in kochia ripening, is because kochia ripens later than most of our crops, especially wheat. You can see the kochia growing; it stays greener, so we can actually see that, and actually satellite imagery. Which I would say that there's a ton of free satellite imagery out there that's available for farmers to use these days. And then I know I've revamped my fourth year class this year, and that's been kind of a theme, is like to try to make it a digital agronomy course. So essentially, so that to teach students how to use some of these sources out there. But so for some things, you like kochia. Yeah, that's the bunny slope. We know we can see it. We know we figured out kind of how to do it. We know that it's associated with specific soil characteristics like salinity. Wild oat is like trying to ski an avalanche chute to try to find the difference between wild oat and that. You know, of course, the easy way is going between the rows. I don't know if we have that image still up there of inter-row cultivation. That, you know, of course, if the wild oat grows between a crop row, it's pretty easy for using imagery to detect where crop rows are and to kill the weeds between it. But for finding the spectral or shape-based differences between wild oat and wheat, that's really difficult. You know, it's not impossible though. It's not impossible, but it's difficult. It's very difficult. So for some weeds, yes, and certainly I know we have another project where we're using shape recognition, both from using a classic image analysis method and also using a deep learning convolutional neural network approach to separate weeds out. And yeah, you know, separating wild mustard out in a wheat field is pretty darn easy. You know, it can be done. There's a lot of ways you can do it, but again, wild oats and wheat. And those of you that have done this, you know what you're doing. If you've been through a weeds lab, you're pulling apart you're pulling that leaf off, and you're looking to see if there's an auricle or not. But otherwise, if you're a farmer, you just carry a trowel with you and you dig it up to make sure. But maybe can we switch back to my slides for a second? I just wanted to show a slide or two to relate a little story about this, that maybe it is possible. Let me know when we're back there.
I think we're still on your slides.
Okay, we're still on my slides. we'll move. Oh, there we go. This is where I want to be. Can anybody see? Can you see a picture of an old sprayer?
Yeah.
Okay, so that sprayer you see there represents my first experience I ever had with weed control as a young man. And that is a sprayer that my dad built in the early 1960s, early to mid 1960s. I can't remember how, but near the end of the 60s, I would ride on that with my dad. You see that old Army, there's an old Army, beneath where the regular seat is, there's a lower level, and there's an old toolbox there from an old Army shell casing. And I would sit in there and ride with my dad. And this was an old Oldsmobile, from somewhere in the 50s rocket Oldsmobile that had a V8 engine with a 4-barrel carburetor. And they used this to spray carbine on their wild oats at the time. And my dad actually, he had a pair of sunglasses at the time that he said he could detect the slight difference in tint between wild oat and wheat. And as he was going across the field, he would spray. We were spraying carbine at this time. You could only spray it in the 2-leaf stage, so you had to cover your entire farm pretty quickly to get it in that 2-leaf stage. You see, too early and too late. But they do this, and he actually had a precision weed management system at that time. But sadly, his precision weed management system ended when he was hauling some grain and shoveling out a granary, and his sunglasses fell out of his pocket and went into the grain auger and got chewed up. And he was never able to find another pair, he said, with the same tint. I guess I wanted to say that it is possible. Me riding on this old sprayer may help explain why I've done a fair bit of work in organic weed control. Where the boom is compared to where I would have been. That was probably a strange thing. Yeah,
well, I think
so
we're all going to be out watching some of those sunglasses now.
Yeah, exactly. Yeah, but so there is potential, and so precision ag systems. The idea for them has been around for a while, and we've seen some test machines out there that actually would have applicability under organic systems. Like the Bonnie Rob, which would have a sensor and find the weed. And then many of these systems that are in the kind of, I would say, the early to mid development stage don't actually use herbicides. They're actually going for a mechanical, some type of little hoe or something like that, or in some cases water jets or something like that. So there could be potential for something. Again, the wild oat one, finding the difference between wild oat and wheat. If you're having to bend down on your knees, humans have an amazing visual ability to detect shapes and shades and stuff like that. And people can talk about hyperspectral or NDVI. I've been working with this stuff for at least half a decade now, and I'll tell you, there's no magic in any of this stuff. The differences are subtle. There's no magic peak in wild oat that makes it different than anything else. It's just subtle differences in the pigment reflection that you can see. So it's not going to be easy, but it is certainly could be possible at some time in the future. And there's just some more pictures of that's some of our work with kochia, looking at kochia as a weed. I know it's become more of a problem in the Red River Valley. Of course, we have, for conventional farmers, we have that wonderful evolution of glyphosate tolerant. I say wonderful, tongue firmly in cheek. Glyphosate tolerant. Here, just showing how, in this situation here, showing how the areas that are red, high salinity around the sloughs, the areas that are red, that's where we tend to find our kochia plants, and this is becoming kind of a large. And here's just some. We also have a UAV that is capable of quite good resolution, and a 22-minute, we can fly a quarter section about 20 minutes and get quite good resolution as well. So that's some of the areas we're looking at, but that's strictly research kind of stuff. Yeah.
I think it'll be really interesting to see, going into the future, what kinds of things we can learn about how we spread. But I think your point too, nothing's magic, and we still have to learn about how the weeds grow and the physiology, and the best ways of managing them is important. We have a few more minutes left. I'm going to ask a couple more questions from the chat, if that's okay with you.
Sure, that's great. Yeah, I'd love to hear that.
Yeah, so, and then anything that we don't have time to get to today, we'll try to address and send out to everybody. So if I don't get to your question, I apologize. So one of the questions here is asking if any research has been done on underseeding clover or any other kind of cover crop with tame oats to specifically control the wild oats, and is it effective, and is there any negative impact on the yield of the tame oats?
I'm not aware of any research specifically, but anecdotally, I've seen. I know I was involved in one research project, and this is just one site year, where there was this little bit of clover. The clover was planted with the cereals, and I could not believe how much reduced the weed population was in that. And I don't do any cover crop research or anything like that. So I don't. Maybe Catherine, maybe you would know. You guys, I think, have done more work like that in Manitoba than I've done.
Myself specifically, I don't have direct experience with that, but I think, I have seen anecdotally, again, underseeded clovers that have been effective at reducing weed populations, but I wouldn't know about how that affects the yield of your cash crop.
Oh yeah, well, having the clover that, usually the clover is like, if it's just looking a little spindly under your crop, and then when your crop starts drying down, it starts taking off, you're okay. Like your crop, when your crop starts drying down, it's just in the process of dying. It's like that salmon that just swam back to that stream, and it's reproducing, and it's just in the process of dying at that point.
Yeah, no, exactly. Yeah, so I think for that person who asked that question, I can do a bit of digging and see if there's any more work that we can share with you. What interesting, or two questions that kind of are related that came up was a little bit about how does wild oat affect the quality of a tame oat? And have you personally seen any consumer or market demand for wild oat products?
Okay, so we actually published on that with Chris Willenberg way back in the day. And other than the wild oat actually being in there as a contaminant, it doesn't affect the quality at all, hardly any difference. So maybe under some, if there's a terminal drought or something, it could affect your bushel weight a bit, but it doesn't. Crop quality is almost all determined by, it's determined by two main things: variety and environment. And the influence of agronomy on it is very, very, very minor in most situations, other than if you're looking for things like protein, which are directly related to nitrogen. But physical quality, almost nothing. And then the second one was an interesting one.
Have you seen or heard of any markets or consumer demand for wild oat products?
Well, I don't know. I've seen it for sale. Robinhood used to, when they bought Robinhood used to, the wild oats they clean out of their flax, they used to mill them and sell them. I don't know if they still do. Actually, a little side note, I got over at Paddockwood Breweries, they used to do custom brews, very pico batches of for home brewers. They would make you the wort or something, and I actually had them make me a wild oat stout years and years ago, which was quite good. So maybe there's some.
That's probably the best use for wild oats, honestly.
But wild oats are they're good quality. They're basically, wild oats are kind of they have higher protein because they don't have as much carbohydrates. Oh, are we out of time? We see there. So they're really, again, think of it as a tame crop, as just your wild cousin.
That's great. Okay, I think Karen showing up is telling us that we've run out of time to chat. Steve, I just really want to thank you so much for participating today. It was great to hear from you. It was great to do this with you. It's like the good old days. I'd like to thank everybody who participated in the questions. There was a lot of really good questions on the webinar. There's a few that we couldn't get to, or if you have follow-up questions, I'm sure I'm stealing what Karen was just about to say. Sorry, Karen, but we will try our best to get to all of these questions. It's great.
Well, I'd like to
Karen, go ahead.
I'd like to thank all the listeners out there for their great questions. That was super fun. Thank you guys for inviting me on this.
Great. Well, thank you both for leading us through the tricky wild oat issues that most of us who are farming here have had. So I just want to thank again some of our sponsors for this episode, for this webinar. So we have FCC, Weed Surfer, Fresh Hemp Foods, which sells its hemp food products under the brand Manitoba Harvest. We've got Entz Brothers, who are John Deere equipment dealers. And finally, we have Roquette, who are looking for organic peas in 2021. We also want to thank our team, everyone, again, especially today, Catherine, for moderating this and helping to get through the questions. And like she said, we'll be emailing answers along with the presentation at a later date once we get those answers for you. So our team is also led by Laura Telford, and we thank her for helping to organize all of this, and University of Manitoba's Natural Systems Research Group. So tune in next week. We have our next webinar on the 2nd of December, and it's green and yellow foxtail, and it'll start again at 12 p.m. and we have Dr. Robert Golden and Ian Grossart who will be presenting at that webinar. So thank you very much for joining us today, and we'll see you next time.